the last specific example we're going to look at is a P2 configuration, something like a carbon atom, something like I mentioned at the beginning. Now, for each electron, we can have it be spin up or spin down, and it can be in the m equals -1, 0, or +1 orbital, or if you want to think of it as px, py, and pz, right? It could be in each of those possibilities. And so electron 1 has 6 possibilities, right? Spin up, spin down for each of the 3 orbitals. And electron 2 can be anywhere but where electron 1 goes. So 5 possibilities, which if we take 6 times 5, that's 30 total. But we can't tell electron 1 and electron 2 apart. So half of the possibilities are going to be exactly the same as the other. So divide by 2, 15 total possibilities. Okay, and these are the potential configurations we can have with a P2 configuration, something like carbon atom. Now, to save on a little bit of time, I went ahead and drew these out in advance. So I'm going to scroll down here. And these are our 15 possibilities. I've represented this with our M value, or M sub L value, is going to be the left-hand side represents +1, middle 0, right-hand side -1. And then I've represented spin up and spin down with up and down arrows. All right, and so underneath this, I'm going to go ahead and list out what are the M sub L and M sub S values for each of these configurations. As we saw with the previous example, it's really these Z components that let us know what are the values of L and S that we can ascertain from these. Okay, so this example here, we have spin up, spin down, so overall M sub S is equal to 0, but M sub L is equal to +2, right? Because we have 2 electrons in a M sub L +1 orbital. Okay, so we have 2, 0. Maybe let's do this in a different color so it's easier to see. We'll do it in red. 2, 0. All right, so this next example, they're both in M sub L equals 0, so it's 0, 0. And then we have -2, 0. Okay, so now we have 2 spins in the same direction, both spin up, but only one in the M sub L positive, 1 in 0. So we have a M sub L of 1 and M sub S of 1, so 2 plus a halves. All right, and so I'll keep going through these. We have here -1, +1, because again, spin up. And here we have 0, +1. Here we'll have +1, -1, because we have 2 spin downs, so it's 2 -1/2 M sub S values. Here we have -1, -1, and here we have 0, -1. Here now our spins are paired again. We have a spin up and a spin down, so our M sub S value is going to be equal to 0, but we will still have orbital angular momentum. So here we have +1, 0. We have 0, 0. We have +1, 0 in a different way. And just scroll down to our last 3 down here. Here we have 0, 0 again, but in a different possible configuration to get that. Here we have -1, 0, and -1, 0 again, just with the spins flipped. Okay, so we have a bunch of different possibilities now. So we have 15 different things we're looking at. I'm going to use my different colors here. So what are our maximum M sub L and M sub S values? So our maximum we have here is a +2 and a -2. And that tells us that we have to have at least an L equals 2 state. So we have, because we have max M sub L of +2 and -2, our maximum and minimum, right? So there must be a term that involves capital L equals 2. All right, if we look at our S values, our largest possible value is +1 and -1, and we have those repeated a bunch of times. So our biggest possible S value is that we have S equals 1. And we may have some other ones as well. Same for the L, capital L. All right. So let's look at what we have. If we look at those +2 and -2 terms or configurations, so coming back here, whenever we have a +2, it's accompanied by a 0. And same thing with the -2, it's accompanied by a 0. So that means the S value that goes with our L equals 2 has to be equal to 0, because when we're at our maximum M sub L values, we're also at our maximum M sub S, and it only goes up to 0. So that tells us that we're going to have an L equals 2, S equals 0 term. All right. And M sub S is equal to 0 for all these possibilities. And so this is a singlet D2 configuration. All right. So if we eliminate, so if we have a singlet D2 term that goes with this, that means we're going to have, we can kind of eliminate all of our ones. All these configurations can only belong to one term. All right. So we can eliminate this one and this one. And we're going to have terms as well where we have, +1 and 0, -1 and 0, which will be one of these down here. Doesn't really matter which one we consider. And then we'll also have a 0, 0 term. So that could be any number of these, but we'll pick this one. All right, so these 5 configurations, I've somewhat picked arbitrarily. We allocate to this L equals 2 term, right? The singlet D2 term. And then we assess what we have left over. Okay, so we have terms where we have M sub L, our maximum is 1, but we also have cases where M sub S is 1 as well. All right, so if we kind of take this 1, -1 here, -1, +1, again, we'll still have a 0, 0 involved in here, right? So what we see is that we have another term where we have L equals 1 and S is also equal to 1. All right, and so we have one case with M sub L equals 1, M sub S, and S is equal to 1. And we also have some L equals, right, we have, if we look at the M sub S values, we end up with, whenever L equals 1, we have our 0, -1, 0, and +1 are kind of associated with that. Coming back up to looking up here, right, we see that we have a positive M sub S value, negative M sub S value, and we also have cases where we have -1 and a 0 that goes with it, right? So if we can take our let's pick a different color. We'll use this rainbow here, right? All of our cases where we have a -1, -1, -1, and we have 2 different, actually no, that one's one already eliminated, but this one over here, we included this, it's already crossed out. But these 3 cases where we have -1, we have 3 different M sub S values. We have a +1 M sub S value, a -1 M sub S value, and a 0 M sub S value. So we can see that there's an associated S equals 0 that goes with this L equals 0. Okay, and that tells us we have an L equals 1, S equals 1 term that goes here. Okay, and so that is going to be a triplet P2 term, a triplet P state. All right, well, actually, we can't define specifically what J, there's going to be multiple J values here. Okay, so there's 9 possibilities there. We can have, just to kind of keep track of how many more we have left, we can have M sub L equals +1, and there's an associated M sub S equals -1, 0, +1, M sub L equals 0 with an associated M sub S equals -1, 0, and +1, and M sub L equals -1, again with 3 different M sub S values associated. We can pick those out from our configurations above. Okay, so that is, we had five configurations here. This is a total of 9 configurations, so 9 and 5 is 14. We only have 1 left. And so our 1 configuration that's left, once we take all those out, is actually one where we have a 0, 0 term. Something like this one. All right, and I'll write this one in white. So our 1 configuration that's left is L equals 1, sorry, not L equals 1, L equals 0, S equals 0, and this is a singlet S 0 state. Okay, so our different terms we have, and again, let me remove the J values here because that's the next thing we're going to talk about. And I think I'll go ahead and start this as a new video to start talking about right, so we have three different terms that go with this: singlet D, triplet P, singlet S, and we'll look at the J values in the next video.